Hi, I'm Manu Shantharam. I'm a researcher in SDSC and I'm part of the user services group for both Expanse and TSCC. Today we'll be talking about customizing Python environment on TSCC. So in the title of the agenda, it said Miniconda, and so here it will be Python environment. It could be pip, Miniconda, Anaconda, or something else. So I just want to cover all these things. And I'm going to turn off my video so that I maintain my bandwidth. And in case we have Q&A, I'll turn on my video. Let me turn it off. Okay. So, okay. So this cartoon basically shows most of the Python ecosystem we have. Like we try to install a bunch of things, different versions of Python, and finally it all gets messy. So how do you deal with this? To give a concrete example, say we have 4 different applications and there are a bunch of, say, TensorFlow packages, TensorFlow 1, 2, and 2.x, where x is some version where there is some fix for a bug in TensorFlow 2 or a new feature. And there are 2 versions of Python. Say you want to run all these things on TSCC. How would you go about doing it? In this example, application 1 runs TensorFlow 1 using Python 2. Similarly, application 2 uses TensorFlow 1, but on Python 3, and so on. So if you have something like this, how would you exactly go about dealing with this? So for these things, you have a bunch of tools to manage your Python environment. Here I have just listed some of them, which include Python's pip, Python Conda, which has both Miniconda and Anaconda. There is Python virtual environment, which I'll talk about. And there is also Conda-Pack, which I got to know very recently through Madi. And I have been testing on it. And it is a work in progress for me. So I just thought I'll just share that as well. Okay, now, why do we need Anaconda? Hold on for a minute. Okay, why do we need Anaconda? So for any user, one of the primary requirements is for a stable, flexible Python environment or environment in general. So user might want to use Python 2 on certain things, Python 3 on certain things, but from a support standpoint, it is a pain because users would want to use different versions of Python, different modules, some of which would be really old modules. And there could be convoluted dependencies. Anaconda allows users to manage all these kinds of dependencies. Hence, if you're a user, it's easier to use Anaconda or Miniconda, whichever you're comfortable with. Okay, here is a quick introduction to how you can go and install Anaconda on TSCC. Note that I'll cover that later, but Anaconda is a big, it takes up around gigs of disk space, as well as it is a package that contains hundreds of modules, whereas Miniconda is a smaller version of Anaconda, and you can control what you want to install instead of installing a bunch of unknown packages. Okay, here is how you would install Anaconda. First, we need to go to this particular URL. Then there's a download link from which you select Linux version. And then you download this particular, which is the latest one that is present once I tried it out today. So this is the latest one. Now, once you do a wget, so it takes around 5 to 10 seconds on TSCC. This example shows that this particular file got downloaded in 3 seconds here. And once you download the shell script, you would have to install it. To install, you just do a bash, that's shell script name. And here you see that there are a couple of timings. The first box, which is given, can you guys see my mouse?
Yes, we can see.
Okay, cool. So there are 2 times. The first one is some version of Anaconda that was installed way back in 2019. Here you see that it took just 5 minutes. I installed it today. It took me an hour, more than an hour. So I'll talk about this, but note that whenever you install something on TSCC, either on your home directory or on your OS's Scratch, they are shared file systems. And if you do these installations from a login node, these are shared nodes as well. So the timing can vary from few minutes to tens of minutes. Okay, assuming you are successfully able to install Anaconda, you might get a warning message based on the Python path. If it is set, it will try to warn you. And it will also ask you whether you want to put the initialization commands in your bash RC. In this case, I apparently said no. I didn't want to say no. Since it was not progressing, I just hit enter, and I think it propagated and said no. So once you say yes, everything will be in your bash RC. If you don't, then you would have to activate your Anaconda installation manually, which I'll cover. So now, as I mentioned earlier, this particular installation, I didn't choose yes for it to update my bash RC. So I had to activate my Anaconda environment. I do it using source and the path. And when I do a which Python, it tells me the Python that it is using. And you can see that it is if I do a Python without activating, this is with activating. You see that Python version is 3.8.8, whereas I think system version is 3.6, which probably again we'll see. So now once you have Anaconda, you can go and install certain packages that were not installed by Anaconda by default. Here is an example. This particular bio from sequential IO or seq IO, when I try to import from this Anaconda environment, it says that there is no such module. Then we go ahead and install that module using conda install biopython, and when you import it, you see that it is there. So here the takeaway is, although we say Anaconda, when you install Anaconda, it installs a bunch of packages, it doesn't necessarily mean it installs all the packages that you need as a user. And here is one command where conda install package name will install the package. And this is a very basic version, say, because it tries to search for this package in particular channels. If those channels are not present, then you need to probably give a channel name like -c Conda-Forge or something like that to search for the package. Okay, so this is an outdated slide. I wanted to keep it just to show that once you install Anaconda and you also install a package using conda install, in this case GraphViz. When you try to import that package, you still get an error. You would have to install it using pip and then see it. This particular example doesn't work as presented in the slide, means it works properly. But a takeaway from this is, it is possible that once you do install using conda, it might still not be able to import it. Okay, now I have talked about Anaconda, installation of Anaconda in general, but the title in the agenda says Miniconda. What is the difference? This figure basically sums up the difference. Conda is a package manager. Miniconda, you can think of it as a workbench, whereas Anaconda is more like a hardware store consisting of all kinds of tools. So in text, Miniconda only has Conda and its dependencies, whereas Anaconda includes some thousands of packages, out of which probably around 200 packages are installed by default. In my case, when I installed it today, I saw around 340 packages. And since Miniconda doesn't use so many packages, it installs quicker than Anaconda and takes a lot less space than Anaconda. So here is a link to, just a minute. All these windows are hiding. Okay, I don't know how to hide floating controls. Okay, so here is a link from Stack Overflow, which says when you can use Anaconda and when you might want to choose Miniconda. It's based on users' preference and flexibility. Once Anaconda is installed, Conda list gives you the list of packages. This is a very short list of packages. Here you can see the package name as well as the version and the channel that I mentioned before. And here you can see that this particular version of Anaconda installed 348 packages by default. Now, we have installed Anaconda, but how do we address the problems that I had mentioned before? Say you want to use TensorFlow 1 and 2 for some couple of applications. How do you do that? So we work with environments. It's a way in which you can change your Python version or your Python package versions and so on. This can be done in various ways. For the next few slides, I'll just cover how you can do that using Anaconda or Conda. So first thing you need to do before doing any environmental, running any environmental command is to update your Conda base, which you can do by running Conda update -n base Conda. Since I installed everything fresh, everything is there, so nothing gets updated. Now, how do I create a specific Conda environment? Here, the first example, Conda create -n py37 Python 3.7. This creates an environment which has Python 3.7. Here, py37 is the name I have given, whereas Python equal to version should be specific. And similarly, you can create an environment for certain packages. Here I'm using YAML, but you can use a different version of TensorFlow. And notice here that I have -c Conda-Forge. Here, Conda-Forge is the channel where I can find this YAML version. If you don't use this -c Conda-Forge for this particular case, it'll say that didn't find this package. So once, say, I have created those environments, how do you see what environments you have? For that, you need to run this command, which is conda info -envs. Once you do that, you'll see that there are 3 environments. The first one is the base, and there is a Python 37 or 3.7 environment, and there is a YAML 24 environment. So you might create lots of environments, and that could create problems for you to know what is what. So for that, you can also purge the environments that you don't need. For that, you can say conda remove -n, the name. That will remove an environment for you. Now, once you have all these environments, how do you actually work with those? So here is an example of doing that. First, I activate my Conda, because once I log into TSCC, it doesn't have my Conda environment, as I didn't populate my bash RC. So I have to activate it. Once I have activated, you see that Python version is 3.8.8. Now, how do I activate the virtual environment that I created, which is, say, Python 3.7? For that, you need to use the command conda activate Python 3.7. Once you do that, you'll see that the prefix has changed from base to Py 3.7, and the Python version is 3.7.11. And say you do your experiments and now you want to revert back to 3.8.8. What do? You just deactivate the current environment, and you see that prefix has changed back to base. And when you do a Python -v, you see that your Python environment is 3.8.8. So this is the way of switching between the environments. Now, we have talked about Conda. There are other tools as well, like Python pip and Python veny, which can be used to manage users' environment. Let's talk briefly about those two. It's interesting. Every time there is a person who needs admission, my floating panel comes back. Sorry. Okay. So pip is an inbuilt installer program to install Python modules. So this is present by default starting Python 3.7. Before that, you would have to install it. To install a module using pip, you can run the command Python -m pip install and the package name. If you run this command, it by default installs the package in the environment where your Python 3 is from. For example, you just log into TSCC and try to install something, you might have issues because it will try to install it at the system level, which you don't have permissions to. It will fail. But if you activate your Conda environment and try to install, it will install something in your Conda environment. And say you logged into TSCC, no Conda, but you want to install something using pip. You can use pip install -- user flag. You can use this so that it installs locally to the user. And here are some of the commands that you can use. Show package, it will show details of the package, where it is installed, the version of the package, and pip lists all the packages that are present in your Python environment. So this is an interesting package, pip rex. So here pip3 install piprex installs the package called as piprex. What piprex does is it helps you to generate requirements from any project. For example, I have been developing a project where I use a bunch of Python modules like bokeh, numpy, pandas, and so on. And all these are used within my Python application, which imports these packages. But if I want to give that program to somebody else, then they wouldn't know what packages to install. They have to try to run it, you get an error, install that package, and so on. But once you have piprex, all you need to do is go to your folder, where source of the folder where you have your application, piprex dot, it'll basically go over your program or the application written in Python, and it will create a requirements document. Let me just show you an example of that. So I did a, where is it? piprex.i. So is this visible, or do I need to make it bigger? I'll anyway make it bigger.
Yeah, that's helpful. Looks good.
Okay. So I did just piprex dot, and it creates a requirements file, which is, it says what are the requirements. Once you have this requirements file, you can actually install the package install all these packages using pip -r flag, this requirement.txt. So this way you don't have to really think how to share a file or a Python code that has a bunch of dependencies. Okay, now coming to veny. So I should have used this red bullet in the previous slide. Say I don't want to use Conda because it has a bunch of things which I really don't require, and I can manage a minimal set of packages on my own. How do I do that? One is you can use pip. The other one is you can use veny. Before going into veny, let me just cover some quick basics of how Python installations work. So Python packages can be installed at different locations, installed not at, into different locations based on how you install it. So a lot of system packages gets installed under sys.prefix, which for TSCC/user. So if you just go to TSCC and type in Python 3 and import sys and do, you'll see this. And some of the third-party packages can also go into the location pointed by sites.getSites package on TSCC. I think I did it on TSCC, and these are the various locations at which they get installed. So what does Python venv does is it creates virtual environment so that various projects that require such isolation can have their isolation. So here each project can have its own dependencies. Note that whenever you create a virtual environment, no site level packages are included in your virtual environment by default. And once you create your virtual environment and do a Python import sys.prefix, you'll see a different location which corresponds to the Python that you're running. And another interesting aspect is once you are in your virtual environment, you can use pip and install any package in your virtual environment. You don't need to use -- user flag because everything gets installed within your virtual environment. Here are some of the commands to create virtual venv. For Python 3, you can just say Python 3 -m venv env. Here, env is the name of the virtual environment I'm creating. And for Python 2, where venv is not present, you can first install virtual env, and after that, you can do a virtual env. Okay, now I have covered 3 different ways to manage Python environment, and I'm probably running out of time. So I'll quickly go over Conda-Pack, which is a new tool, interesting tool. So as I mentioned before, sometimes Conda install or even activate can be too slow. Means if you have been running Conda on TSCC, you would have definitely noticed this. And there is no single place that you can point to saying that this is the reason why it is slow. It could be various reasons. It could be shared file system. It could be the login nodes, or it could be some user running something which is causing the slowdown of shared resources. So here is an example that I illustrated before, where I installed Anaconda on my home directory and it took an hour. And the same script I ran on the local scratch of a compute node. And here you can see that I spent just 1 minute installing this. So this is cool, right? You are saving a lot of time. So when you install something on the local scratch of a compute node, it gets purged after the job. So whatever you have installed it is gone. Unless you try to install it on a shared space, then again, you will run into that slowness. So is there a mechanism in which you can install something and then on scratch space, temporary scratch space, and then move it to whatever shared location later on to just use it? So Conda environments are not relocatable in the sense that you cannot install in some directory and you cannot just move it and say it will work out of the box. It won't. So for that, the Conda-Pack is the useful tool to circumvent those two issues. So what it does is it archives the Conda environment, which can be installed on any other systems and locations on the current system where you have installed using Conda-Pack. So here, I just want to mention that when I say any other system, it may not work. Say you installed something on Windows and want to move it to Linux, it won't work. Probably it will probably look for some kind of compatibility with respect to operating system. And the other limitation is once you say installed your Conda environment using Conda-Pack, you cannot redo the Conda packing on that particular installation. Okay, so some of the useful commands for Conda-Pack are: first, you need to install Conda package using Conda-Pack. It's either using this or the Conda Forge channel. So let me show you an example. I'll exit from this. Okay. Okay. So here is a setup. Setup Conda, sorry. So basically, the script I adapted from whatever version Marty had sent me. And here you can see that I'm downloading a Miniconda version and I am creating my own environment using environment.yaml. Means here I say what all packages have to be installed. So I'll show you what that is. And once all the Conda installation is done, I create Conda-Pack. And this is the packaged Conda install. And I copy this into the Scratch. Here I'm saying Scratch, which is a parallel file system. You can copy it into your project space as well. So once that is done, next thing is here I'm testing it. Basically what I do is I retrieve the package into the local Scratch, which is here. I extract the package, I activate it, and I run an example. Once I run an example, I'll see that I'll see the different package information that I'm printing. So if you look at this, I'm printing that my particular environment had NumPy version, whatever, pandas, so forth. And in terms of what this package, let me just I just wanted to show you what that environment.yaml file does. So if you look at this, I'm just naming this environment as stats2, and it has two channels. One is Conda Forge and the other one is Anaconda. And I installed these packages. And in my test application, I just printed. So basically, this is one way in which you can avoid installation on your home directory directly. Once, say 100 users are installing Conda, if not concurrently or in an overlap fashion, then the login node will just give up. So this is one way in which you can do it on a local, you can run your code on a local scratch, which is way faster depending on whether your code can be run on local scratch. For example, if you have a MPI program, probably you cannot. So yeah, depending on whether you can, this Conda-Pack usage will be really useful. And I'm going to post these test files as well as the slides into the repo that Mary had posted. And let's see if I have something else. Example. Okay, that's it. And one more quick thing that I have, which I have not done this, but you can use Conda to install R as well. And you can try it out. I have not tried it out. I just wanted to mention it. And are there any questions? Let me check the chat. Oh, there are 21 questions now.
I think Marty and Scott have been answering the questions.
Oh, okay. So
keeping up.
Okay. And I think, yeah, I'm already 2 minutes over time. And let me know once I'll be back online around 3 when there is hands-on. And if there are any questions, I can take them. And I will upload these files into the repo soon.